In this short video, we want to know a bit more about one of the most famous partial differential equations in science and engineering, the reaction-diffusion-advection equation, which is also called the transport equation. In its general form, the equation looks like this, where U is a scalar quantity and a function of space and time, which can be, for example, temperature in heat transfer or concentration of ions in mass transport studies. In fact, the equation describes the transport of this scalar quantity and the behavior of its evolution. Let's have a look at the special derivatives here. You see a couple of mathematical identities related to multivariable calculus, the reason of which is, as you saw, U is a function of multiple variables. The gradient of a scalar function f is a vector whose components are the partial derivatives of f. Pay attention that this is the most general formulation for 3D space, but you can simply omit the terms to reduce the dimensions for two-dimensional and one-dimensional cases. The divergence of a vector field F is a similar concept, but it operates on vectors and produces a scalar quantity. A combination of these two identities results to Laplacian, which is the sum of second partial derivatives of the function with respect to each independent variable. So, what each term is responsible for? The first term shows the evolution of U over time. The second one is the famous diffusion term, showing how U diffuses in space. The third term is the convection or advection term, which shows how U is affected by a velocity field V. And the last term can be for a wide range of different phenomena, but for our case, it's mainly intended to reflect how U reacts to the world, is generated, or is consumed. Let's have a look at some examples of this equation with different shapes but with the same structure. Heat transfer in solids, mass transfer in corrosion process, in this case magnesium corrosion in sodium chloride, and Navier-Stokes equations for describing the fluid flow behavior. Can you see the pattern? The temporal evolution term, the diffusion term, the reaction term, and the advection term.